Okay, we're looking at mini test week 29, question 2. So we've got a particle moving in a plane and we're given its acceleration as a vector. And then we are given information, well, we're told its velocity specifically at the point when t equals 2. And then we're asked to find just the general expression for the velocity in terms of t. Okay, right, so let's just get the question up. Okay, so what you need to recognise for this question is that you're going to need to integrate. So obviously there's no indication, there's nowhere does it say integrate this. That's what we need to know. So we need to know that velocity is going to be the integral of acceleration. Okay, because the actual integrating itself is really not too tricky. So just like for question 1 where you were differentiating, you can just integrate the I component and the j component separately. Okay, and the one that where you do need to be careful though is that you don't forget the constant of integration. So I've got 2 ways I can lay this out, and it really is whichever way you prefer. So one is just to do the integration. So 4 is going to integrate to 4t. 2t is going to integrate to 2t squared over 2. So that's just going to be t squared. And then I can put the plus c as a separate vector. Okay, your alternative, so you do not do it both ways, but you can just choose how you think it makes most sense to you. So your alternative would be to put the constant of integration within each within the I and the j vectors. So I could use plus c for the constant for the I vector, and maybe plus d, because the 2 constants obviously won't necessarily be the same. Okay, and you can use either of those. They are the same thing, just whichever way makes most sense. So I'll carry on with the way I've done it in black, seeing as that's how I wrote it first. Okay, so that's my integral, and just like when you're in core maths, when you integrate and then they give you a value of x and y to substitute in, they've given me a value of t and then a velocity vector I can use. So when t is 2, the velocity vector is 2i minus 5j. Okay, so if I substitute that in to this, so the velocity is, the velocity is 2i minus 5j. And then if I substitute t is 2 into this, I am going to get, so 4 times 2 is 8, 2 squared is 4, and then plus that velocity vector. So then, if I want to find out what c is, I'm going to minus the 8i from the 2i. So that will give me minus 6i. And I'm going to minus the 4j from the minus 5j. So that would give me minus 9j. And that would be my constant of integration. So then if I go back to that, my full vector for the velocity, well, I'll tell you, so what I can do, or what I should do in fact, is, so what am I trying to do? That's right, okay, so I'll write it out sort of a bit messily to start with. I don't just mean my handwriting, but I'll write it completely unsimplified. So there was the original vector I had after I integrated, and then we've just said that c, or the vector c, is minus 6i minus 9j. Okay, but I really shouldn't leave it like that. So just like collecting like terms, I should, oh, for goodness sake, sorry, I should write my I vectors and my, the colour we haven't used, my j vectors together. So I should write that as, so my I vector, I've got 40 and then also minus 6i, and then for my j vector, I've got t squared minus 9j. And then just to finish off, It's a velocity, so I should put the units. Okay, so if you prefer to do it this way, you would get exactly the same thing. So if you laid it out that way, you would have just got that capital C was -6 and capital D was -9. Okay, but you should end up with exactly the same final vector. Okay, and then, right, so part B is quite nice and straightforward. So calculate the speed when t is 5. So there's only really one thing to be careful of here. So first of all, let's get the velocity when t is 5. So if I sub t is 5 into that, that's going to be 20 minus 6. So that's not 24. It's going to be 20 minus 6, so 14i, plus 25 minus 9, so 16j. Okay, so the only thing to be careful of is I need to find the velocity to answer this question, but that's not the final answer. And this comes up a lot where they basically ask the magnitude. So the speed is the magnitude of the velocity. So 14 squared plus 16 squared, all square rooted. It's just using Pythagoras. So 14 squared plus 16 squared, all square rooted. So if I give it in exact form, it's going to be 2 root 13. And if I give it to 3 significant figures, it's going to be 21.3. Okay, so either of those is fine because it didn't ask for it in any specific form.